So we have to fill up this sheet for these instructions. I will help you filling it out for the first few cycles, and then you have to complete it yourself the rest of the sheet. Okay, so we have to do this activity together for the first few cycles. I will let you know how to fill this out. So I designed this activity myself just to help you understand when the forwarding signals should be set to whatever the value is supposed to be, and what will be the value of the hazard detection unit, the mux related to the hazard detection unit. Okay, so let's proceed ahead. So we have this program. Let me zoom it a bit. So we have these 4 instructions in our program. So I'm starting to solve this activity sheet. So first of all, what you do is you write the instruction, the first instruction, which is LW x2 40 x1. So this is the instruction which will go into the instruction fetch during clock cycle number 1. Okay. What are the instruction in the next 4 phases? There is nothing initially. Okay, so you can just simply write not applicable and just line it out. Okay. Next, in the next clock cycle, the instruction, so the LW instruction will reach to this stage, which is LW x2 40 x1, and in this cycle number 2, in the instruction fetch phase, it will be the next instruction, which is add x4, x2, and x5. Do you follow? So if you look at this diagram just down below, during in this second phase instruction decode, what will be the content of IFID, this register IFID RS1. So RS1 here is x1, right? What is RS2? RS2 is nothing. No, it's not 40. 40 is an immediate data. RS2 is nothing, so you can just simply put a dash in here. And then RD is x2. Okay? What is S? Or let me ask you first this IDX mem read signal. So we are assuming that we are in the clock cycle number 2. Okay? So clock cycle number 2 has not been finished yet. So IDX is this register. What is the value of IDX.mem read? We do not have anything stored yet, because all the contents will be written once the clock cycle is finished. Okay, so it is not 1 yet. So we can just simply write dash here. We do not know this value. Okay, what is the value of S? S would be, S is here. So it should be 0. Okay, because it should be fetching all the control signals, normal control signals. Okay.
Why IDX memory is not 0?
Why would it be 0? Because IDX mem is currently empty. No instruction has reached that far yet. Okay. By the end of the clock cycle number 2, these the data related to LW instruction will then be stored in IDX. Okay. Once the clock cycle number 2 is finished. Okay, so we are in the clock cycle number 2. And again, there is nothing down here, so you can just simply write NA. In the clock cycle number 3, this is important. Now again, same instruction, you write LW, X2 has reached here, 40, X1. The next instruction is here, add X4, X2, X5, and another instruction would be fetched, which is OR X4, X4, and X2. Okay, just try writing the values of RS1 here in the execution phase, which is RS1 is again X1, there is no RS2, RD is X2. Okay. What do you think would be the values of forward A and forward B? So forward A is this, forward B is this. So forward A is what? 2. Why 2? Because the data is coming directly from the IDX register. Okay. So IDX forward A value would be 2. What about forward B? It will also be 2. Okay. Now see here, what about RS1, RS2 and RD here in the add instruction? So RS1 is X2, RS2 is X5, RD is X4. Okay. What is the value of IDX.memRead? So IDX memRead value is, hold on, what is the value of IDX memRead? What do we have in the IDX register? What instruction do we have in this register? Tell me. Load instruction. And in load instruction, memRead value is what? What is the control value of memRead? It reads the data from memory, right? So the control value should be 1. Okay, so IDX memRead is 1. Okay. Now we have the RD here. RD here is X2. Let me change the color. RD here is X2. And RD here is X2, which is also equivalent to RS1. Okay, so there is a data dependency, right? And this signal also tells that this is the load data dependency. And in load data dependency, we have to convert the instruction to a bubble or no operation instruction. How can we do that? By controlling, by deasserting all control signals to 0. How can we do that here? With the help of this S signal. So this S signal, what should be the value of this S signal? It should be 1, right? Okay, when this is asserted to 1, what will happen? This instruction will turn into no op instruction. So we have NA here. So by the time LW reaches here, LW X2 40 again X1, okay, again RS1 is X1, RS2 is 0, RD is X2. Okay, what do I write in this execution phase? What is the instruction here? What is the instruction in this phase? It's a no op instruction. Okay, so it will turn into no op. So you will simply write no op. Okay, what do I write here in the instruction decode phase? Is the same instruction will retain here, add x4, x2, x5. Okay, and the same thing, x4, x5 and x2. And here in this case, IDX memRead signal, what will be the value of IDX memRead now? It will be 0 and S should be 0 as well. And here the same instruction OR, which will move forward then. And the clock cycle number 5, when LW reaches here, its RD is X2, right? And this NOP will be moved to this phase, this stage of the pipeline, and here add instruction will move at X4, X2, X5. Okay, again RS1 is X2, RS2 is X5, and RD is X4. This one will contain OR, X4, X4, X2, you just fill that out. RD is X4, RS2 is X2, and RS1 is X4. What will be the value of IDX memRead? 0 again, S is 0 again, and the next clock cycle contains here add X9 and so on. I have not written the XMEM RS1. Okay, so what will be the value of RS1 here? It will be the same thing because add instruction is still moving. So add instruction which was which was turned into NOP in this phase, okay, this instruction will still move forward, which means the x4, x2, x5 will still be RS1, RS2, and RS5, okay. So you have to specify whatever the values of. So first of all, tell me what will be the value of forward A and forward B in this cycle. Forward B will be 2, and forward A look carefully. See the next instruction. The instruction in the memory phase has an RDX2, okay, and NOP instruction has RS1 X2. This one should be, wait a minute, let me write, X2, RS2 is X5 and RD is X4. Although it's a no operation instruction, but there must be some values because forwarding unit will be playing its role. It has to select some values. So what will be the value here, forward A? You see X2, this is writing into X2, and what, there is a data dependency here, X1. RS1 is X2. So when the xmem RD is equivalent to IDX RS1, then the data must be forwarded from xmem phase, okay? So it must be 0. Now you need to fill out the forward A, forward B values of this one and turn the sheet. You have to fill it up yourself, okay? And the quiz, the bonus quiz is based on these questions. You have to do it individually.